Assalamualaikum. I'm Farhana Maisara binti Nur Azlan from AS 11617. Today I'm going to talk about thermochemistry. For your information, there are some changes in energy when a chemical reaction occurs and usually involves heat energy. When a chemical reaction occurs, heat energy is either released or absorbed. We have two types of reaction, which is exothermic reaction, endothermic reaction. As we can see, this picture shows about exothermic reaction. Exothermic reaction is a reaction that releases heat to surrounding and surrounding temperature will increase. Respiration is an example of exothermic reaction. During respirations, carbohydrates present in food are broken down to form glucose. Glucose combines with oxygen in the cells of our body and provides energy. Oxidation of glucose takes place, producing large amount of heat energy. That's why respiration is considered as exothermic reaction. Okay, let's move to endothermic reaction. Endothermic reaction is a reaction that absorbs heat from surrounding and causes the temperature to drop. This picture shows photosynthesis process. Photosynthesis is an example of endothermic reaction because sunlight energy is absorbed by green plants during this process. Okay, now I need to use slide because I need to show you guys something about energy level diagram. The heat released or absorbed during a reaction is called the heat of reaction. Okay, in this topic we have two symbols. And as you can see, there is a triangle symbol. We call it as delta. Delta is a fourth letter in the Greek alphabet that denotes difference or change. For heat released or exothermic reaction, we need to put negative symbol in front of delta. And for heat absorbed or endothermic reaction, we need to put the positive symbol in front of delta. Students usually forget to put the positive symbol because they assume this like mathematics, because in mathematics we don't put positive symbol for positive values, but for this topic we need to put positive because it shows endothermic reactions. The energy change in a chemical reaction can be represented using an energy level diagram. Energy level diagram shows the difference in the heat energy content between the reactants and the products. Heat of reaction is the heat change of 1 mole of reactant that reacts or 1 mole of products that is formed. The reaction between zinc and hydrogen chloride forming zinc chloride and hydrogen gas is an exothermic reaction. When 1 mole of zinc reacts with 2 mole of hydrogen chloride to form 1 mole of zinc chloride and 1 mole of hydrogen gas, 126 kJ of heat is released to the surroundings. The total energy content of the products is lower than the total energy content of the reactants. Therefore, heat of reaction is negative. So as we can see, the energy level diagram for exothermic reaction looks like going downstairs. So that's how I remember the energy level diagram for exothermic reaction. The reaction between copper 2 oxide and hydrogen gas forming copper and water is an endothermic reaction. When 1 mole of copper 2 oxide reacts with 1 mole of hydrogen gas to form 1 mole of copper and 1 mole of water, 130.5 kJ of heat is absorbed from the surroundings. The total energy content of the products is higher than the total energy content of the reactants. Therefore, heat of reaction is positive. So how I remember the energy level diagram for endothermic reaction is, I just remember that the shape is like going upstairs. Okay, so how can we construct the energy level diagram? As you can see, this is an example of energy level diagram for exothermic reaction. So first of all, you need to draw an arrow upwards. Then you label their energy. After that, you draw two energy levels. Then write the reactant and the product of the reaction at the correct energy level. Next, draw an arrow from the energy level of the reactant to the energy level of the product. Lastly, write the value of heat of reaction. Okay, so let's move to next subtopic, which is heat of reaction. We have 4 types of heat of reaction. Number 1, heat of precipitation. Number 2, heat of displacement. Number 3, heat of neutralization. And number 4, heat of combustion. In this topic, we have some calculation. These are the steps for calculation. Let me explain about the equation Q equals to mc delta. Q refers to heat of reaction, M refers to mass of medium, C refers to specific heat capacity of the reaction medium, and delta refers to difference in temperature of the medium. The number of moles, N, is according to the types of heat of reaction. Mole of precipitate formed for heat of precipitation. Mole of metal displaced for heat of displacement. Mole of water formed for heat of neutralization, and mole of fuel burnt for heat of combustion. As we know, heat of reaction has 4 types. So, what is the meaning of each type of heat of reaction? Okay, so let's start from the heat of precipitation. Okay, so heat of precipitation means the heat change when 1 mole of precipitate is formed from their ions in an aqueous solution. The second one is heat of displacement. So, heat of displacement is the heat change when 1 mole of a metal is displaced from its salt solution by a more electropositive metal. The third one is heat of neutralization. Neutralization is a reaction between an acid with an alkali to produce only salt and water. The heat of combustion is the heat released when 1 mole of a substance is completely burned in excess oxygen. Okay, I think that's all from me. Thank you for watching.